All right, this is lesson, what is it, 35? Is that the right number?
I think so.
Yep. Solving systems of equations with elimination. The same thing as last week, except today's going to be even a smidget harder, okay? So, same type of steps, so same steps as last week. The big one for today is step number 2. Again, you have these written down already, so I'm not worried about you having them written down. But step 2, if a variable cannot be eliminated, multiply the equations to set up the lines or to eliminate. So here we go. Watch me do numbers 1 and 2. Okay, ready? So numbers 1 and 2. First thing I would do on each of these is always name them 1 and 2 on the first equation. And then I'm going to look at my x's and see, are my x's the same? No, they're not, so I can't eliminate the x's. Look at my y's. Can I eliminate my y's? No, they're not the same. Okay, so now we're kind of in trouble. So we need to figure out what can I multiply to get rid of my x's. So can I multiply 4 with anything to get 3? No. Okay, let's think backwards now. Can I multiply 3 with anything to get 4? Technically you can, but not. I want a nice integer to multiply with. Let's look at our y's. Can I multiply 3 with to get anything to get 8? What about 8 with anything to get 3? No. So now we have to find, we're kind of stuck. Now we have to find a common multiple that I can multiply my coefficients with to get a common coefficient. Okay, so I could work with my x's or my y's. You just need to pick one or the other. So I'm going to work with my x's, and I want to figure out what is the lowest common multiple of 4 and 3. So I would take 4 and 3, and you're going to find the lowest common multiple. So just like you're doing a fraction problem. So we got 4, 8, 12, 16, and so forth. And then we got 3, 6, 9, and 12. And you see the lowest common multiple here is 12. Okay, so I want my x's to both look like 12s. Okay, right now they don't. So I'm going to take equation 1. I'm going to put parentheses around it. What do I multiply 4 with to get 12? 3. Okay, so I'm going to multiply everything by 3. So I'm going to make a new equation. We're going to call it equation 3 now. Okay? So we're taking equation 1, multiplying it by 3. 3 times 4x is 12x. And then we got 3 times negative 3 is negative 9y. And then we got 3 times negative 6 is negative 18. Okay? That's my new equation 3. Now I have to think about equation 2. I'm going to put parentheses around equation 2. What do I multiply 3x with to get 12? Because I want it to look like this. What do I multiply 3x with to get 12? 4. Okay? So I'm going to make a new equation. We'll call this one equation 4. It's just a new improved equation 2. Okay, so 4 times 3x is 12x. 4 times negative 8 is negative 32y. And then 4 times negative 16 is negative 64. Okay? So I'm going to draw a line. And now my x's have the same value, same coefficient. And really these equations are exactly the same. They just look different because we multiplied into them, but now they have a common coefficient of 12. So looking at equations 3 and 4, I want to still focus on my x's. I want to try a plus and minus sign. So 12x plus 12x is 24x. I can't eliminate it, so I don't want to use a plus sign. 12x minus 12x works. That eliminates them. So we got negative 9y minus negative 32y is going to be positive 23y. All right? Yep. And then we got negative 18 minus a negative 64, which is going to be positive 46. Okay? Then I divide both sides by 23. We get y is equal to 2. Okay? Look at that. Y is equal to 2. Now, just like before, once you have one of them, you just plug it back into any equation. I'm going to pick equation 1. Go back to the beginning, putting in y, substituting 2 for y. So we got 4x minus 3y, and instead of y, I'm substituting 2, is equal to negative 6. Oh, negative 6, not 16. Okay? And we're just solving. So we got 4x minus 6 is equal to negative 6. Add 6 to both sides. We got 4x is equal to 0. Divide both sides by 4. X is equal to 0. Okay, so we're going to put our answer as 0, 2. All right, did y'all see that? All right, watch me do number 2. Maria, do you remember doing this? Mm-hmm. Okay, are you excited still? Mm-hmm. Okay. You're not as excited as last week. I'm a little concerned. No. Okay.
I'm tired.
I bet. Okay, number 2. So we got 12 is equal to 4x minus 3y. So everything's kind of disorganized on this one. And then we got the second equation, 0 is equal to negative 12x plus 14y plus 36. So the first thing, we have to organize everything. So let's take the first equation. I'm going to rewrite it. So I'm going to put the 4x, just switch sides of the equal sign. So I'm using the symmetric property. 4x plus 3y is equal to 12. And then the second equation, I want to do the same thing, except I'm going to add 12x and subtract 14y on both sides. Okay, when I do that, I'm going to get a new equation too. It's going to be 12x minus 14y is equal to 36. Okay, this is my true equation 1 and 2. All right, so on this one, look what's going to happen on this one. We're going to focus on our x's. Is there anything I can multiply 4 with to get 12? 3, right? Okay, so I'm going to multiply equation 1 by 3. So we got our new equation 1 is going to be 12x plus 9y is equal to is equal to 36. And then equation 2 is going to be 12x minus 14y is equal to 36. Okay, and when I do that, I could just subtract the second equation. So we're going to, these eliminate. 9y minus negative 14y is positive 23y. And then 36 minus 36 is just 0. So y, again, is equal to 0. Actually, y is equal to 0 on this one specifically. So my answer, I'm going to put 0 as my y coordinate. Plugging it back into whatever equation I want. I'll pick equation 1. Okay. Equation 1 said 4x plus 3y. And we said y is equal to 0. So we're going to put 3 times 0 is equal to 12. So we got 4x plus 0 is equal to 12. 0 disappears, we got 4x is equal to 12. Divide both sides by 4x is equal to 3. So we plug in 3 as our x coordinate. So 3, 0 is our second answer. Okay? Does that make sense, everyone? Okay, so on these two examples, sometimes you have to multiply both to get a common coefficient. Sometimes you have to just multiply one, but you have to organize, okay? So these are the hardest problems, okay? So, and not all the problems will look the same. Not all of them you'll have to reorganize. Not all of them will be problems where you have to multiply. You just have to know when to multiply, okay? So let's have 1 solid 2 is about number 1. 2 solid 1 is about number 2. Ready, set, go. Number 3. Okay, so we got 2 equations. Write these down. You can write them down on your papers, on your notes. And then, okay, on your notes. Shh. So write these down, please. Write this down. We got 2 equations. So let's focus on the x's. Can we multiply 9 with anything to get 6? No. Can we multiply 6 with anything to get 9? No. Okay. Can we multiply the 2 with anything to get 3?
No.
No. What about 3 with anything to get 2? No. So we need to figure out a common coefficient, okay? So you were talking about solving for the y's all the time, right? So let's solve for x this time. So let's focus on the y's. Okay, so we got 2 numbers. What is the LCM of 2 and 3? 6, right? Because we know the multiples of 2 are 2, 4, 6. The multiples of 3 are 3, 6, 9, right? So the lowest common multiple is 6, right? Do you follow me? Okay, so we have to ask ourselves now, we're going to focus on the y's. What do I multiply 2y with to get 6y? 3. So I'm going to multiply this first one by 3. And what do I multiply 3y to get 6y? 2, there you go. So we're multiplying each one of these differently, okay? Ready? So we got 3 times negative 9 is negative 27x. You're all writing this down with me, right?
Yeah.
Because I don't hear you and see you doing that. You're not writing it down. If you don't want to write it down, that's fine. You'll stay with me in 5th grade.
What if we already started
The other way?
solving it for x? Like, yeah.
That's. Then you are in the wrong direction right now. Oh, did you multiply the x's? Is that what you're saying?
Yeah.
Oh, that's okay. You can still get the same answer. You're just going to have different numbers until you get there. Okay, so 3 times negative 9 is negative 27. 3 times negative 2 is negative 6y. And then 3 times negative 9 is negative 27. Okay, so this is our new equation 3. Shh. Okay, next one. 2 times 6 is 12x. 2 times negative 3 is negative 6y. And then 2 times positive 6 is positive 12, okay? So now we have a new equation 4. And look at our y's, they were both the same, okay? So since they're the same, they're negative 6, we use a minus sign on the outside because we know that negative 6y minus negative 6y is going to be 0y, right? These cancel out. So negative 27x minus 12x is negative 39x, okay? And you might be worried that their numbers are going to get bigger, but don't worry, they're always going to simplify and work themselves out. Then negative 27 minus 12 is going to be negative 39, okay? Divide both sides by negative 39, and we get x is equal to... What's negative 39 divided by negative 39?
0.
No.
Divided.
1. Positive 1. Okay? Okay, so now that we know that x is 1, we plug it back in. It doesn't matter which one you plug it into, equation 1, 2, 3, or 4. So I'm going to just pick equation... let's pick equation 2 because that's the easiest one, it looks like. So we got equation 2, I'm going to rewrite it, so then replace x with 1. So we got 6 times x, or 6 times 1, minus 3y. Oh, I'm sorry. Is this? Yeah, 3y is equal to 6. Okay. So we got divide both sides, or this is equal to 6. So we got 6 minus 3y is equal to 6. Subtract 6 from both sides, we got negative 3y. Still not working, right?
Yeah.
Oh, I don't see you working. Negative 3y is equal to 0. So y is equal to 0. Okay? So 1, 0 is your solution here. Okay? Alright, so these get pretty hard, right?
Yeah.
But like I said, we solved this time for x, or x first. Last time we'd always solve for y. Remember your question?
Mm-hmm.
So this time we solve for x first, and you're going to still get the same answer. Believe it or not, you will, okay? So it doesn't matter where you start, you should always get the same answer. Alright, these are hard problems. These are going to be on your test Wednesday. Okay? So I suggest that you practice. You have homework tonight, so I'm going to end the lesson there because we ran out of time.